So today I'm doing a presentation on passive house design at the University of Salford. Just here to help the students understand, 10-step guide that we've written and help them with their projects and help them understand the implications of it really. Cutting to the chase then. So our 10-step guide for passive house design. So what I wanted to do really was talk you through the steps that I would recommend. I think it's worth mentioning at the start that although you can follow these steps, quite often you need to go back to the earlier steps and revisit stuff. And throughout the whole process, like I touched on earlier, there is a piece of software, the Passive House Planning Package, or PHPP, which is used alongside your design process, and that can be used as a design tool as well. Designing a passive house is one thing, and then actually delivering it on site is also another thing, which is arguably even harder because contractors perhaps are learning to do things a little bit better at the moment. So that's another thing to bear in mind as well. And obviously stuff happens on site sometimes that changes things. So great. So the first point is orientation. If you've got a blank site, and you're wanting to put a building on it or a number of buildings, the first thing really you want to be thinking about, and this applies to bigger schemes like master planning as well, is orientation. If your objective is to achieve passive house design accreditation, then the orientation of your building will have arguably the biggest impact on its performance. And the reason why that is basically because in the UK, obviously the sun rises in the east, sets in the west, is primarily from the south. And to achieve passive house design, what you need to do is you need to capture the sun and make the most of it, but then also not have, and it's that balance really of heat loss and heat gain. So by orientating your sites to the south, you can manage the sun basically, and I'll come on to shading and other aspects of window design later. Sometimes there are obviously bigger constraints or significant constraints like existing buildings or existing infrastructure that might make it more challenging. And that's why, you're thinking about innovation and creativity at an early stage can make a big impact as well. So once you've got your building orientated, the next thing to do is to consider the shape of the building. Okay, and this is really quite a fundamental point that I didn't really appreciate, to be honest, before doing my passive house training, which is something to bear in mind. And I feel like once you understand this point, you start to see things quite differently in the built environment and in the world of architecture as well. And the big point that I really wanted to make on this one was to maximise your ratio of volume to surface area. Your building has obviously got a certain volume and it's got a certain surface area. If you have a very long, thin building, you actually increase your surface area dramatically compared to the volume of the building, and actually all your surface area is essentially potential heat loss and inefficiencies. So what's really important in passive house design is to keep your building as almost compact as possible and to make that surface area to volume ratio as efficient as possible as well. The bigger the better. The bigger the building, the actually easier it is to achieve passive house design as well, which is quite interesting and worth bearing in mind. Obviously, if you've got like a row of terraces, that also makes a more efficient shape because you've got less heat loss through the fabric of the building. Something else to bear in mind is any projection on a building form will also drastically kind of reduce its efficiency through increased surface area. So if you can imagine this geometry here, if there was a single story kind of projection on the side here, you'd be adding the surface area of the walls, the roof and the floor, and you'd actually be having a substantial more heat loss through all that building fabric. So trying to think in a compact way is really important as well when you're designing for passive house. Sometimes it's actually slightly beneficial to have a slightly elongated south facade because you're getting more solar gain through that elevation as well. Another thing that I was going to touch on as well was the National Space Standards. So I'm not sure if you guys are aware of that, but if you're doing any residential design, there's a set of national space standards to tell you how big properties should be or what their minimum standards should be as well. So whenever we're master planning a site, that's almost in part of this. At this stage, really, when we're thinking about the shape of the building, we look at those national space standards to work out good sizes. Interestingly, we actually do a lot of work over in North Wales, and a lot of their space standards are actually the opposite. They have, rather than minimum space standards, which are the national space standards, they also have national maximum space standards to make sure that properties are affordable as well. So there is almost like a sweet spot between those really when you're designing houses. It's worth being aware of. I remember when I was at uni and when I was tutoring at Manchester, quite often houses were substantially larger than they perhaps should have been. So it's something to bear in mind. Great. The third point really was insulate. And you might think, well, this is a technical thing, but really the reason why it's kind of high up on the agenda is because of the footprint, the amount of space that, highly insulated building components will take up. And it's worth having those built into your design from an early stage to help with the flow of the RIBA stages with the consultants. Passive house design, one of the fundamental aspects of it is to have a highly insulated building fabric. You've got huge amounts of insulation in the walls, in the roof, and in the floor, and that obviously takes up more space. So if you end up designing a project up to a certain level and you put in more conventional wall thicknesses, actually trying to add that thickness later on in the process can be a challenge basically, with constraints or budgets or whatever. So making sure that you've got realistic wall thicknesses in from the start is really important. I think it's fair to say most kind of passive houses are probably highly insulated timber frames, which then aligned, internally or externally with additional insulation to prevent cold bridges through the fabric. If you are building like a passive house, which is more traditional with bricks and blocks, then your cavities might increase from 150 or up to 250 basically. So you've got to bear these things in mind really when you're designing a passive house from an early stage. So you've orientated your building, you've got the geometry sorted, you've got an efficient surface area to volume ratio. We've talked about your wall thicknesses as well. The next thing is to lay out your building. What is the best way to lay out a passive house? And I think probably the biggest point here is to think about the larger spaces basically. Within your passive house, you've probably got lots of glass on the south elevation, and you've got smaller windows on the east, the north, and the west generally. And by having those large areas of glazing, you're going to get a lot of heat gain. And actually having your larger living spaces, which obviously suit the larger windows, on that south elevation is an important kind of first step, really. Usually when you lay out a building, usually put the bigger spaces in first. So that's an important thing to remember. But there are also lots of other things to consider in layout, which you might not consider in a conventional building. So another thing to bear in mind is the service infrastructure that you need to put into a passive house. Because a passive house is very well insulated and extremely airtight, we need to provide mechanical ventilation to every room of the house. I'll come on to the services section, I think it is next. But what that means is you're going to need some kind of mechanical vent heat recovery system, which will ideally locate in the centre of the house or near the centre of the house to reduce duct roots. So that's worth bearing in mind at an early stage. You can't really shoehorn these things in. At later stage, it's better to kind of get ahead of the game with these things. And even if you're not necessarily designing the whole system, you need to allow the space for it. And you need to be thinking, actually, how can I service those rooms by having a centralised plant room, basically. An MVHR unit, if you're not aware, stands for mechanical vent heat recovery. And that basically means that you're bringing in fresh air from the outside and you're passing it over the exhaust air from the inside, and that's your heat recovery. So you're getting warmed fresh air basically coming into the building. Each room in the building then will either have a supply duct with fresh air, or it will have an extract duct. And the rules are that you provide fresh air to your living rooms, your bedrooms, and you do extract air from your kitchens, your bathrooms, your utility rooms. And there's a balance as well that happens in the house or in the property, where the same quantum of air needs to come into the building as being extracted. There are also transfer spaces as well, so you might have a living room and a corridor and then a utility room, and actually that corridor doesn't necessarily have to have supply air or extract air. It can be a transfer space for the property. So trying to think about these things from an early stage when you're laying out your building is really important to make that efficient design process, basically. Other things to consider are the clustering of services. So similar to what I was saying about the plant room, if you can cluster your services together, things like kitchens and bathrooms, you can reduce the service runs of hot water, pipe work, and ducting as well, basically. Finally, another thing to consider in terms of layout is trying to mitigate heat loss, in the winter through opening of doors as well. So your front door, ideally you wouldn't necessarily want that to be opening, but a bit like you were talking earlier, Fadi, here in the winter, you perhaps have a lot of heat loss through the front door or whatever. So having, let's say you're designing a domestic property, you might consider like a vestibule or a porch or some kind of shelter basically at the front door, so you're not having huge amounts of heat loss from the front door, particularly not opening onto a big open plan space. Okay, great. Number 5, services. Like I said earlier, we need to plan the ventilation systems and ducts in a simple and compact way. And I think this is probably one of the biggest differences between designing a passive house and designing a normal house, is you need to take into account the MVHR system. Traditionally, or historically, I should say, buildings have been quite leaky. You've been having almost like natural ventilation through drafts or chimneys. As buildings have been getting more and more airtight, they've been introducing things like, trickle vents. But it's absolutely fundamental in passive house design that the ventilation is managed not only to achieve good air and fresh air, it's also to avoid things like condensation and as well, and create a very healthy environment. So I skipped ahead there, yeah. So with services, you can see there the ducting that's required. Usually you're going to have ducting in your ceilings and you're going to be dropping down into each room, and then you're also going to have service risers through the building. And you want to keep everything as compact as possible so it takes up less space basically. It's also important for your services to be located on an external wall so you can extract. There's so much information that I'm throwing at you here. I just wanted to give you a bit of an overview so you're aware of some of the considerations. And there's lots of information online as well that you can research and find out about these things in a bit more detail. See if I missed anything on here. Like I said, you've got to plan your air path routes through the building. Which spaces are supply, extract, or transfer, and make sure you accommodate these things on the floor plans, basically. When you're designing the services, it's also worth considering the heating strategy for the building. Space heating, hot water heating, and storage as well. From my experience and speaking to kind of experienced passive house contractors and designers, they actually don't advocate the use of hot air for heating systems for passive houses. They'd recommend more traditional kind of heating systems, like even things like radiators or underfloor heating, as they're much more controllable, and they can also tie into things like air source heat pumps as well, which is an important part of renewable sustainability. Okay, number 6, fenestration. So, like I touched on earlier, your passive house design is going to be carefully analysed throughout the whole design process, and it's only at the end of it that you can see whether it works or not. And a big way that you can tinker with the performance of a building is to look at the amount of fenestration. There's basically like an energy balance that each window will perform. It will allow a certain amount of energy in. It will also create a bit of heat loss, obviously, through it. And so if you've got a big window on the south elevation, you're going to attract more heat. If you've got a big window on the north elevation, you're probably going to lose more heat than you're going to gain. So it's a balance, really, that energy balance through each glaze component. Big windows, like I said, on the south help increase the energy from the sun whilst reducing it on the other elevations. I think that's the key principle, obviously. A lot of these things as well, I'm talking about are very technical, and I think what the challenge is to make passive house design attractive as well. I think hopefully some of these examples you can see that it doesn't have to be a box with small windows or whatever, and I think that as architects is what we've got to embrace, really, creating almost like a style which is extremely high performing but also extremely successful as well aesthetically. As well as supplying the natural light, the windows should also be considered for natural ventilation. So what you'll often find in buildings these days, and you might have come across this in the news, is that there's overheating issues because buildings obviously become more insulated. There's often more glass as well, and an important part of the Passive House planning package is to analyse the amount of overheating, which is a huge consideration. As you can imagine, on a hot summer day, if you don't want the building to be so uncomfortable that that it becomes unsuccessful, basically. So one strategy that you can use in passive house design or in any building design is to think about the natural ventilation of a building throughout those hotter days to create those breezes and cross flows of air. And something that's really important to consider this is trying to design openings on different elevations, basically. If you had two openings, let's say on this building facade here, and you open that door there and open that door there, you're actually not going to get very good cross ventilation because there's no differential of air pressure. If you had a window, for instance, on the side of this building here, and then a door there, and if you were to open up the door and the window, all of a sudden you get a much better natural ventilation route through the building because of the differential of air pressure. And that basically is due to the natural kind of winds or whatever that that are surrounding the site. By having two openings on the same facade, you don't achieve anything near the same amount of cross ventilation, basically. So when you're designing your building, you should also be thinking, how am I going to cool this building down on a hot day? How am I going to shelter it from the summer sun using shading? But also, how am I going to naturally ventilate the building through different openings as well? That could be a big challenge, obviously, when you're doing apartment blocks and you've only got one elevation to work with as well. Finally, on the fenestration, a really important way of making windows more effective is by positioning them in the right place. And this, you see this all the time, and I'll show you an image in a few minutes of an unsuccessful kind of window or whatever, but quite often windows aren't positioned in the right place. So obviously you've got your wall, let's just think about a traditional wall where you've got perhaps brick or whatever on the outside, you've got block on the inside, and you've got insulation in the middle. Historically windows have been being positioned either in the brick or in the block, and that creates huge cold bridge issues around the edge of the windows. So it's important to basically consider your windows as a line of insulation, and those windows should be sat ideally within the insulation layer, so that you've got a very consistent line. You're not stepping in or stepping out, otherwise you get cold bridges, you get those cold spots coming around the edge of the windows. So it's a really important technical detail that is being improved, shall we say, with more time. But there's lots of builders out there that struggle to embrace these changes. Number 7, solar shading. Like I said earlier, you need to balance the amount of sun that you get into your passive house to make it generate heat in the winter, but without overheating in the summer. And obviously the way of achieving that is by solar shading. And that's another reason why we need to orientate our buildings ideally to the south, because you can manage it. Obviously in the summer, you've got the sun nice and high, and you can put solar shading in to reduce the amount of solar gain in the summer, which is what you want. In the winter, the sun's low, and it's coming in, and it's heating up the building. And so introducing solar shading is a really important part of passive house design on those south elevations. So you'll often see that as a feature. What is also worth bearing in mind, and I'll come on to this again in a few minutes, is any kind of projection or canopy which fixes onto the facade, you need to be considering as potential risk as well for cold bridging. So these elements will obviously get cold. How is that cold being prevented so coming inside? And it's trying to think about those thermal breaks as well for the solar shading. Another good tip for solar shading is the use of deciduous trees, basically. So in the winter, obviously deciduous trees lose their leaves and they will let the sun come through. And in the summer, they're obviously fuller and greener, and they'll actually shade the building as well. So that's a really good tip for creating some natural solar shading on the outside of your building. Triple glazing, much more commonplace these days. Triple glazing will have a huge impact on the efficiency of your building. And I think it's worth almost thinking of windows and doors as the weakest point in your building. Generally, your walls are 10 times more thermally efficient than your windows, basically. So this is why triple glazing is so important, because it's almost like the weakest point, like I said. And getting some high quality, high performing windows and doors and frames is fundamental really in achieving the passive house goals of reducing that heat loss. So there are certain U values. I don't know if you guys have come across U values for different building components. So depending on where you are around the world, there's recommended U values for glass and also reflectance values. Interestingly, the U value of the glass is quite often not the weakest point. It's actually the U value of the install, or the U value of the frame, or the U value of the spacer. So all of these things have got different U values. And so quite often you'll get a supplier who provides a very efficient glass, but actually if it's not within an efficient frame, or it's not been put in the wall in the right place, or it's not got a good install value, you actually lose huge amounts of heat around the edge of the window, which often doesn't necessarily get the headline of the actual U value of the glass. So there's those 4 different U values that need to be contained, and the analysis of the window installation is another part of it, which is really important when you're trying to create those efficient designs. Yeah, there is actually, thankfully, a Passive House component database, which you can search, which will give you examples of accredited windows and doors. I know there was a Passive House, wasn't there, on Grand Designs recently, which had a Passive House compliant cat flap as well, which is another interesting thing to consider, to be honest. It was more like I don't know if anyone's seen that, but it's like a little door, basically, like a fully sealed little door. So, yeah, triple glazing. Right, next one, number 9, airtightness. Like I said earlier, buildings have been getting more and more airtight. However, Passive House design has such a strict airtightness criteria. You have to achieve 0.6 air changes per hour, a pressure of 50 pascals to achieve Passive House accreditation. And this is substantially harder, or substantially more stringent than building regulations, basically. So quite often in a Passive House, you're going to have to include airtight membranes in your walls that you might not do otherwise, because blockwork is technically not airtight. So considering airtightness in your design from an early start as well is important. And basically, you want to be able to draw a section through your building and have a consistent airtight barrier all the way around the building. A bit like the insulation, you've got a thermal jacket and you want an airtight jacket as well. The airtight membranes are then taped into the windows. Any penetrations, you want to avoid obviously any penetrations coming through that, but any penetrations have got special grommets and special tapes to seal it off. And when you're building a Passive House, it's recommended to have 3 airtight tests during construction, rather than waiting to the end and seeing whether it's airtight. You test, once you've put all the membranes in and you've created the airtight barrier, you test it out to find any leaks before it's obviously covered up. So airtightness is a really important part of it, and obviously these things add a bit to the cost as well. So it's worth getting it in there really, so everyone's on the same page. Usually the airtight layer is on the warm side of the insulation as well. Okay, and then number 10, cold bridging. So this is coming down to the detailing now of the building and thinking about where is the heat loss, where are the most efficient bits and the most inefficient bits. So careful detailing basically at junctions and through fixings to the facade is another area that you can get tripped up on in terms of Passive House design. So this is a thermal image of a building that you guys might recognise. I've actually brought a thermal imaging camera with me today, which I bought a few months ago. And this basically scans your building. You can do it from the inside or from the outside, and you can basically see where the heat loss is happening. So perhaps do it in here after the presentation and see how efficient the facade of the building is. I expect it to be pretty good, obviously, with it being a new building. But quite often for us, if we're doing renovation extension projects, this is a great starting point. We can come to a project and see all the unsuccessful junctions. And like I touched on earlier, you can see here the red is the heat basically from the inside coming through the outside of the facade. So you can see the frames have been really kind of unsuccessful in terms of preventing that heat loss. Other key elements, perhaps you got bridging of the heat coming through this element which is fixed in. So as you can imagine, that's a structural element that's sat on a structural element internally. That's then transmitting or losing some heat to the outside. You can see the fixings here as well. For this balcony, there's probably no thermal breaks in those fixings. And you can also see a huge amount of heat loss at the bottom of the at the bottom of the ground floor slab there connecting. So even on new buildings, I was scanning some of the new towers in Manchester a few weeks ago, and it's still the same story really. It's often the junctions around windows that aren't properly considered. Often what you should be doing is lining the reveals of windows, the head and the side and the jambs and the sills to make sure that there's reduced cold bridging basically. So a cold bridge, if you're not familiar with that term, is basically a weak point in the building facade. It's where the cold is transmitted through the building fabric, often around doors, windows and fixings. As the cold penetrates the internal environment, it reduces the thermal comfort of the space. So basically internally, if you were to be inside in these spaces, the cold would be coming through and it would be creating a cold surface. And that cold surface will actually reduce the comfort of that space, which obviously isn't very, very comfortable or isn't very nice or whatever. But not only that, what will happen is moisture will start to condensate on that cold surface. So you start getting condensation, and that's when you start getting mold growth as well. And that's where it becomes, pretty unhealthy. And that's why cold bridge is obviously so important. It's a comfort thing, but it's also the health aspect as well. Again, there is great resources available for approved details and installation details as well around those things. Great. So that's the 10 steps really. Like I said, we can kind of answer any questions now that you might have or thoughts that you might have on I don't know what you're thinking about, maybe some of your buildings or whatever. And then I can perhaps show you the thermal imaging camera as well if anyone that's interested. So finally, any questions?